July 24th, 1943, Caroline Islands, Central Pacific. Lieutenant Commander Dan Daspit peers through the periscope of USS Tinosa as dawn breaks across the Pacific. What he sees makes his heart race. Dead ahead, lumbering through calm seas without escort, sits the Tonin Maru No. 3, a 19,250-ton Japanese tanker carrying fuel desperately needed by Japan's dwindling fleet. She's massive, slow, and completely alone, a submariner's dream target. Daspit orders his crew to battle stations. The Tinosa maneuvers into perfect firing position. Range, 200 yards. The targeting solution is textbook. At 0928 hours, Daspit orders Fire 1, Fire 2, Fire 3, Fire 4. 4. Mark 14 torpedoes streak toward the tanker. 2 explode, crippling the ship's engines. Tonin Maru goes dead in the water. Daspit allows himself a smile. Now comes the kill shot. He fires 2 more torpedoes. Both hit. Neither detonates. He fires 2 more. Dud. Dud. For the next 9 hours, Daspit stalks his crippled prey like a frustrated hunter. He maneuvers Tinosa into different positions, fires from closer range, adjusts depth settings, fires from the stern tubes. Each time, perfect hits. Each time, nothing but the hollow clunk of metal hitting metal. By 1700 hours, Daspit has fired 15 torpedoes at a stationary target that can't shoot back, can't maneuver, can't escape. 15. Only 2 have exploded. In his cramped captain's cabin, Daspit makes a decision that violates every regulation in the submarine service manual. He orders his crew to bring the final torpedo back to Pearl Harbor, unexploded, for testing. It's a direct contradiction of standing orders. Torpedoes cost $10,000 each, equivalent to $207,000 today. The Bureau of Ordnance has explicitly prohibited field testing that wastes valuable ordnance, but as Tinosa turns for home, leaving Tonin Maru drifting and damaged but still afloat, Daspit realizes something that will change the course of the Pacific War. The United States submarine force has been fighting for 20 months with weapons that don't work. Japanese merchant ships are sailing unmolested. Enemy oil tankers are fueling battleships. Troop transports are delivering reinforcements. Not because American submarines can't find them, not because submarine commanders lack courage, but because American torpedoes are fundamentally, catastrophically defective. What Daspit doesn't know, what no one in the Pacific Fleet yet understands, is that the Mark 14 torpedo suffers from not 1, not 2, but 3 critical design flaws. And the Bureau of Ordnance, the organization responsible for fixing them, has spent 20 months denying they exist, blaming submarine commanders for poor marksmanship and lack of aggression. The torpedo scandal is about to explode in ways the Pentagon never imagined. The Mark 14 torpedo was supposed to be America's secret weapon. Designed in the 1920s by the Navy's Bureau of Ordnance, the Mark 14 represented the cutting edge of naval technology, 21 feet long, 21 inches in diameter, weighing 3,080 pounds, capable of speeds up to 46 knots. Its warhead packed 643 pounds of Torpex explosive, enough to crack a battleship's hull, and its revolutionary Mark 6 magnetic exploder was designed to detonate beneath enemy ships, breaking their keels with hydrostatic pressure, a one-shot kill. The problem? The Navy never properly tested it. In 1931, torpedoes cost $10,000 each. The Bureau of Ordnance, operating under severe Depression-era budget constraints, conducted exactly 2 live-fire tests. Both tests used torpedoes fired from a surface barge, not from a submerged submarine at combat depth. Both tests used dummy warheads, not live explosives. The Navy declared the Mark 14 operational and began mass production. December 7, 1941, Pearl Harbor burns. American submarines deploy for war patrols carrying Mark 14 torpedoes. Within weeks, Combat reports flood back to Pearl Harbor headquarters. USS Sargo fires 13 torpedoes at 3 Japanese cargo ships. 1 ship sinks. 12 torpedoes. Nothing. USS Skipjack fires 13 torpedoes at 4 different targets in perfect firing solutions. 0 hits. USS Seawolf unloads 8 torpedoes at a Japanese cruiser from point-blank range. All 8 run under the target without exploding. The pattern repeats across the Pacific, 60 to 80% failure rate. Submarine commanders report 3 distinct problems. Problem 1. Torpedoes run 10 feet deeper than set. Set a torpedo for 10 feet depth, it runs at 20. Set for 20 feet, it runs at 30. The weapons pass harmlessly beneath enemy hulls. Problem 2. The magnetic exploder detonates prematurely, or not at all. Torpedoes explode 50 yards short of the target, or they hit the target dead center and just bounce off. Problem 3. Even when the magnetic feature is disabled and torpedoes hit enemy hulls directly, the contact exploder fails. Perfect strikes, no detonation. The submarine force's solution: improvise. Experienced commanders like Dudley Mush Morton on USS Wahoo began disabling the magnetic exploder against explicit Bureau of Ordnance orders. They set torpedoes to run shallow, risking broaching on the surface where they'd be spotted. They fired spread patterns of 4 to 6 torpedoes, hoping at least one would work. But the failures continued, and the Bureau of Ordnance blamed the submariners. Rear Admiral Ralph Christie, who'd spent years developing the Mark VI exploder at the Bureau of Ordnance before taking command of submarines in Australia, refused to believe his creation was defective. Admiral William Blandy, chief of the Bureau of Ordnance in Washington, wrote memo after memo insisting the Mark XIV performed within acceptable parameters. The problem, they insisted, was operator error. Submarine commanders weren't aggressive enough, weren't getting close enough, weren't calculating firing solutions correctly. Some submarine captains were quietly relieved of command, not for incompetence in battle, but for criticizing the torpedo. The expert consensus was clear and devastating. The Mark XIV was fine. The submarine force was the problem. By mid-1943, the situation had reached crisis levels. Japan's merchant fleet, the lifeline supplying oil from the Dutch East Indies, rubber from Malaya, food from Indochina, sailed with near impunity. American submarines scored occasional victories, but nowhere near the tonnage kills needed to strangle Japan's war economy. Intelligence reports showed Japanese oil tankers completing round trips that should have been suicidal. The stakes couldn't be higher. Navy strategists had calculated that crushing Japan's merchant marine was the key to Pacific victory. Cut off Japan's resource imports, and the empire would collapse from within. But with only 20% torpedo success rates, that strategy was failing. Submarine crews called the Mark XIV by bitter nicknames the Mark XIV Dude, the Bureau of Ordnance Special, the torpedo that wouldn't. Morale plummeted. Men were dying, not from Japanese depth charges, but from frustration and rage at weapons that didn't work. USS Tang would later report, "We came here to sink ships. Instead, we're wasting time watching torpedoes bounce off enemy hulls like rubber balls." Something had to change. Someone had to prove the torpedoes were defective. Someone had to force the Bureau of Ordnance to admit the truth, that someone was about to arrive in Pearl Harbor. Rear Admiral Charles Andrews Lockwood wasn't supposed to challenge the establishment. Born in Virginia in 1890, Lockwood graduated from the Naval Academy in 1912, near the bottom of his class academically. He had no engineering background, no connections to the Navy's ordnance establishment, no political leverage in Washington, just 28 years of submarine experience, most of it spent at sea, not behind a desk. On February 14, 1943, Lockwood arrived at Pearl Harbor to take command of Submarine Force Pacific Fleet, COMSUBPAC. The submariners called him Uncle Charlie, not in mockery, but genuine affection. Because unlike the bureau admirals in Washington, Lockwood had actually served on submarines, had actually fired torpedoes in combat, had actually experienced the crushing disappointment of watching a perfect shot result in nothing but bubbles. His first week as COMSUBPAC, Lockwood reviewed 18 months of patrol reports. The pattern was undeniable. Torpedo after torpedo, dud after dud, and always the same official response from Washington. No defects found in laboratory testing. Then on June 20th, 1943, USS Trigger returned from patrol with a damning story. Commander Roy Benson had achieved perfect firing position on the Japanese aircraft carrier Hyo, one of Japan's most valuable warships. From 1,200 yards, Trigger fired 6 torpedoes. 2 missed. 1 exploded prematurely. 1 was a dud. 2 vanished completely, likely running too deep. The carrier sailed away untouched. Lockwood went to his staff and asked a simple question that would prove revolutionary. Can we test the torpedoes ourselves? His torpedo officer, Lieutenant Commander James Fife, responded with the official answer. Sir, the Bureau of Ordnance prohibits field testing. Torpedoes are precision instruments. Testing must be done in controlled laboratory conditions in Newport, Rhode Island. How long does it take to get test results from Newport? 6 to 8 months, sir, if they agree to test at all. Lockwood stared at the map of the Pacific on his wall. American submarines were dying. Japanese merchant ships were escaping. The entire submarine campaign, America's best weapon for strangling Japan's economy, was failing because of defective torpedoes. And the solution was to wait 8 months for a lab test. That night, Lockwood pulled out a report from his predecessor's files. In June 1942, his predecessor had conducted an unauthorized net test, firing torpedoes into a fisherman's net to measure actual running depth. The results proved torpedoes ran 10 feet too deep. The Bureau of Ordnance's response? They'd modified the depth mechanism, but refused to acknowledge the original problem existed. 2 problems solved. 1 remaining. Why were the contact exploders failing? Lockwood looked at his calendar. July 30th, 1943. Any day now, USS Tinosa would return from patrol. And Commander Daspit had radioed ahead with an unusual request, permission to conduct unauthorized testing on an unexploded torpedo. Lockwood made a decision that could end his career. He picked up the phone and called the submarine base engineering officer. When Tinosa arrives, I want that torpedo disassembled. I want the exploder mechanism tested. I don't care what Bureau of Ordnance regulations say. I don't care if it costs $10,000. I want to know why 15 torpedoes hit a stationary target and only 2 exploded. Sir, that violates explicit BUOR directives. Lockwood's response would become legendary. Then I guess I'm about to become the most court-martialed admiral in the Navy. Get me answers. August 5th, 1943. Submarine base, Pearl Harbor. Torpedo shop. The workshop isn't secret. It's right there on the submarine base. But what's happening inside violates every Bureau of Ordnance regulation on the books. Lieutenant Commander Fife oversees the disassembly of the torpedo Daspit brought back from the Tinosa patrol. Machinists carefully remove the Mark VI exploder mechanism from the torpedo's nose. It looks simple enough, a firing pin designed to strike a detonator when the torpedo hits a target. Basic mechanical engineering. What could possibly be wrong? Fife examines the exploder under magnification. The firing pin shows signs of deformation. Crushed, bent. But how? The pin is made of hardened steel. It should withstand the impact force of hitting a ship's hull. Lockwood arrives at the workshop. What did you find? Sir, the firing pin mechanism appears damaged, but I don't understand how. These are designed to withstand tremendous impact forces. Run an impact test. Sir, we don't have authorization. I'm giving you authorization. I want to know what happens to that firing pin when it hits something at combat speed. Over the next 3 days, Pearl Harbor's torpedo shop becomes an improvised testing facility. They rig up a crude but effective experiment, drop the exploder mechanism from increasing heights onto a steel plate, measuring the impact force that simulates a torpedo hitting a ship's hull at different speeds. Low speed impact, the firing pin works perfectly. Medium speed impact, the pin deforms slightly but still functions. High speed impact, simulating a torpedo hitting at 46 knots, the firing pin mushrooms, bends backward, fails to strike the detonator. Fife stares at the test results in disbelief. Sir, the firing pin is too weak. At combat speeds, the impact force is so great that the pin crumples before it can trigger the explosion. Lockwood's face darkens. You're telling me we've been firing torpedoes that are too fast to explode? Yes, sir. The faster and more accurate the shot, the more likely it is to fail. Every submarine commander who got close achieved perfect firing position and hit the target dead center. Those are the ones who got duds. The irony is crushing. The Bureau of Ordnance designed a high-speed torpedo with an exploder that couldn't handle high-speed impacts. For 20 months, aggressive submarine commanders, the Navy's best, achieved perfect hits and got nothing. While incompetent commanders who missed slightly, causing glancing blows, occasionally got explosions. The Navy had been punishing excellence and rewarding mediocrity. Lockwood orders additional testing. The shop fabricates a lighter, more flexible firing pin. They run the impact tests again. The modified pin works at all speeds. Problem solved. Or it would be, if Lockwood could get the modification approved. On August 10, 1943, Lockwood sends a detailed report to the Bureau of Ordnance in Washington, documenting the test results and proposing the firing pin modification. The Bureau's response arrives 3 days later. Field testing violates established protocols. Recommends sending sample exploder to Newport Torpedo Station for laboratory evaluation. Estimated timeline, 6 to 8 months. 6 to 8 months while submarines continue fighting with defective torpedoes. Lockwood crumples the message and drops it in the trash. Gentlemen, he tells his staff, we're going to fix this ourselves. And we're going to answer to the Navy later. August 15, 1943. Subpac Headquarters Conference Room, Pearl Harbor. The room is packed with submarine captains, men who've risked their lives stalking Japanese convoys, only to watch their torpedoes fail. Lockwood stands at the head of the table, the modified firing pin in his hand. Gentlemen, we've identified the problem with the contact exploder. The firing pin can't withstand high-speed impact. It crumples on contact, preventing detonation. We've designed a modified pin that works at all speeds. The room erupts, not in anger, but relief. Commander Richard O'Kane, future recipient of the Medal of Honor, pounds the table. 20 months of perfect shots turning into duds, and Bureau of Ordnance told us we weren't aggressive enough. Commander Eugene Fluckey, another future Medal of Honor recipient, stands. Admiral, with respect, how is this possible? Buord tested these torpedoes before the war. How did they miss something this obvious? Lockwood's answer is damning. They never conducted high-speed impact tests with live warheads. All testing was done with dummy warheads at reduced speeds. The contact exploder was never tested under actual combat conditions. The room falls silent. Sir, Captain John Cromwell asks quietly, does Washington know about this? I sent them the test results. They've ordered us to cease unauthorized testing and ship sample exploders to Newport for evaluation. Timeline: 6 to 8 months. Another eruption. This time, anger. My men are dying out there. Japanese tankers are running supplies while we fire duds. 6 months? The war could be over. Lockwood raises his hand. Which is why I'm not waiting for Washington's approval. Holland, the submarine tender USS Holland, will begin manufacturing modified firing pins immediately. Every submarine departing on patrol will carry torpedoes with the new exploder. Lieutenant Commander John Scott, Lockwood's logistics officer, stands. Admiral, that's a direct violation of Bureau of Ordnance authority. They could court-martial you, strip your command. They could, Lockwood agrees. They probably will. But right now, I've got submarine commanders bringing their boats back to Pearl with tales of perfect shots that bounced off enemy hulls. I've got crews losing faith in their weapons. And I've got a war to win. If the Bureau of Ordnance wants to court-martial me for fixing their defective torpedoes, they're welcome to try. The room erupts in applause, but the battle with Washington is just beginning. August 20th, 1943. A priority message arrives from Admiral William Blandy, Chief of the Bureau of Ordnance. ComSubpac unauthorized modifications to Mark 14 torpedo stop. Cease immediately. Stop field modifications. Violate weapons. Safety protocols. Stop await official testing results from Newport stop. Lockwood drafts a response, then tears it up. Too diplomatic. He writes another. Board SINCPAC, Submarine Force, has conducted extensive combat testing Mark 14 torpedo. Stop contact, exploder. Fundamentally defective. Stop cannot wait 6 months for laboratory results while submarines continue combat operations with defective weapons. Stop implementing firing pin modification. All submarines under my command. Stop respectfully request. Bureau conduct independent verification stop. Blandy's response is immediate and furious. Lockwood, your actions undermine Ordnance Bureau authority. Stop modification. Unauthorized. Stop recommend. Immediate relief from command stop. Lockwood takes the message to Admiral Chester Nimitz, Commander-in-Chief Pacific Fleet. Nimitz is Lockwood's direct superior, and the only man who can overrule the Bureau of Ordnance. The meeting in Nimitz's office lasts 15 minutes. Lockwood presents the test data, the patrol reports, the 20 months of documented failures. He doesn't editorialize, doesn't complain, just shows Nimitz the numbers. Nimitz studies the firing pin, reads the test results. Finally asks, Charlie, if we implement your modification, will the torpedoes work? Yes, sir. Can you prove it? Give me 2 weeks. I'll send Barb on patrol with modified torpedoes. We'll have combat verification. Nimitz makes the decision that will save the Pacific submarine campaign. Do it. I'll handle Washington. 2 days later, a message goes out from SINCPAC headquarters to the Bureau of Ordnance. Not a request, an order. Subpac modifications to Mark 14 contact. Exploder approved. Stop combat testing to begin immediately. Stop board will conduct parallel laboratory verification. Stop. Admiral Blandy can either comply or argue with the Pacific Fleet's Supreme Commander. He complies. On September 30th, 1943, USS Barb departs Pearl Harbor carrying 20 torpedoes, all equipped with modified firing pins. The war is about to change. If you're fascinated by these untold stories of World War II innovation, hit that subscribe button now. We're bringing you the real history behind America's greatest military turning points, stories the textbooks left out. More incredible documentaries coming your way. Don't miss them. October 12th, 1943, Philippine Sea. USS Barb, under command of Lieutenant Commander Eugene Fluckey, stalks a Japanese convoy. 3 cargo ships escorted by 2 destroyers. The convoy is heading south from Formosa, carrying supplies for Japanese garrisons in the Philippines. Flucky has hunted convoys before, always with the nagging fear that his torpedoes might fail. But tonight, Barb carries torpedoes with Lockwood's modified firing pins. Tonight, for the first time in 22 months of war, Flucky has confidence in his weapons. Bearing, mark, range, 1,400 yards, angle on the bow, 75 degrees, set depth, 6 feet. The torpedo data computer calculates the firing solution. Flucky verifies it manually. Old habits die hard when you've been burned by defective weapons. Fire 1, fire 2, fire 3, fire 4. 4 torpedoes, 4 targets. Flucky counts the seconds. 48, 49, 50. Boom! The first cargo ship's boiler explodes. The ship lifts visibly in the water, breaks in half, begins sinking immediately. Boom! Boom! 2 more hits. 2 more ships mortally wounded. Flucky's sonar operator reports, explosions confirmed, breaking up noises from all 3 targets. For the first time in his submarine career, every torpedo Flucky fired worked exactly as designed. Barb reloads and attacks the destroyers. 6 more torpedoes, 5 hits. Both destroyers crippled, 1 sinking, 1 limping away trailing oil. Flucky surfaces after the attack and radios, Pearl Harbor. All torpedoes function perfectly. Stop 5 ships sunk or damaged. Stop modified, exploder confirmed, operational stop. The message electrifies Subpac headquarters. Over the next 30 days, similar reports flood in from across the Pacific. USS Harder sinks 5 Japanese destroyers in 1 patrol, a record that will never be broken. USS Tang sinks 6 merchant ships in 9 days. USS Silversides completes her most successful patrol, sinking 7 ships. The success rate jumps from 20% to over 70%. Submarine commanders who'd been frustrated for nearly 2 years suddenly become lethal hunters. The strategic impact is immediate and devastating for Japan. In December 1941, Japan's merchant fleet totaled 6 million tons. By October 1943, despite new construction, it had shrunk to 4.1 million tons. Submarine attacks were sinking ships, but Japanese shipyards were building replacements almost as fast. Then the modified torpedoes arrive. November 1943, U.S. submarines sink 97,000 tons of Japanese merchant shipping. December 1943, 156,000 tons. January 1944, 185,000 tons. The Japanese naval staff begins noticing disturbing patterns. Previously, American submarine attacks might damage ships that limped back to port. Now, American submarine attacks result in immediate sinking. Ships hit by torpedoes don't survive. They just disappear. A Japanese naval intelligence report from February 1944, captured after the war and translated, provides chilling perspective. American submarine torpedo performance has improved dramatically since November 1943. Previous pattern showed approximately 30-40% successful detonation rate. Current intelligence suggests 70-80% success. Unknown. What technical improvements Americans have implemented, but result is catastrophic for merchant marine operations. Convoys suffering 60-80% losses on high-risk routes. Oil shipments from Dutch East Indies severely curtailed. By mid-1944, the destruction becomes systematic. U.S. submarines sink 603 merchant ships totaling 2.7 million tons in a single year. The Japanese economy, dependent on raw material imports, begins strangling. Admiral Takejiro Onishi, commander of Japanese naval forces in the Philippines, writes in his diary in June 1944, "The Americans have achieved what their battleships could not. They are destroying our merchant fleet with submarines. Oil shipments from Borneo are at 40% of required levels. Without fuel, the combined fleet cannot operate. We are being strangled." The human cost, on both sides, is staggering but stark in its asymmetry. Before October 1943, U.S. submarines sank approximately 1.1 million tons of Japanese shipping in 22 months, an average of 50,000 tons per month. Japan's shipyards replaced most losses. After October 1943, U.S. submarines sank 4.7 million tons in 21 months, an average of 224,000 tons per month. Japan's shipyards couldn't keep pace. The merchant fleet hemorrhaged ships. The mathematics are brutal. The Mark 14 torpedo fix quadrupled the submarine force's effectiveness. For individual submariners, the difference was life and death. Commander Samuel Dealey, captain of USS Harder, wrote to Lockwood in April 1944, "Admiral, I took Harder on 3 patrols with the old torpedoes, shot fish that didn't explode, watched enemy convoys escape, lost opportunities that cost American lives on Guadalcanal and New Guinea. Now I'm on my 4th patrol. Every torpedo works. Every shot counts. You saved my crew's lives by giving us weapons we can trust." Dealey would sink 16 Japanese ships before his death in 1944, becoming one of the war's most decorated submarine commanders. His success, like that of dozens of other submarine captains, was made possible by torpedoes that finally worked. But the cost of the 2-year delay is impossible to calculate precisely. How many Japanese cargo ships reached port unmolested in 1942 and early 1943? How many enemy troop transports delivered reinforcements? How many oil tankers fueled Japanese carriers at Midway, Guadalcanal, and the Philippine Sea? One naval historian estimated post-war, if the Mark 14 torpedo had functioned properly from December 1941, the Pacific submarine campaign would have strangled Japan's economy by mid-1943. The war might have ended a year earlier. Tens of thousands of lives, American, Japanese, Filipino, Chinese, might have been saved. The Bureau of Ordnance, finally forced to acknowledge the defects, quietly implemented Lockwood's modifications across the entire torpedo production line. By January 1944, all Mark 14 torpedoes, whether fired from submarines in the Pacific or from destroyers in the Atlantic, incorporated the Pearl Harbor firing pin fix. No apology was ever issued. No admiral was reprimanded. The Bureau of Ordnance simply updated the Mark 14 specifications and pretended the problems had never existed. But submariners knew, and they never forgot. This is the untold story of how one admiral's decision to defy regulations saved thousands of lives. If you're learning something new, hit that like button and drop a comment telling us what other World War II mysteries you want us to investigate. Your engagement keeps these stories alive. Admiral Charles Lockwood retired from the Navy in 1947 with 3 distinguished service medals. He never spoke publicly about the torpedo scandal. When naval historians pressed him for details in the 1950s, his response was typically modest. "I just did what any submariner would do. I trusted my captains over bureaucrats." The official statistics, declassified after the war, tell the story Lockwood wouldn't. Total Japanese merchant shipping sunk by U.S. submarines, 4.9 million tons, 1 through 3 Army 14 ships. Total Japanese naval vessels sunk by U.S. submarines, 540,000 tons, 201 warships. Of that total, roughly 55% was sunk after September 1943, after the firing pin modification. The U.S. submarine force, representing less than 2% of the Navy's manpower, accounted for 55% of all Japanese shipping losses in World War II. But that success came at devastating human cost. 52 U.S. submarines were lost, with 3,506 men killed, a 20% casualty rate, the highest of any branch of American military service. And for 22 months, those men fought with defective weapons. Lieutenant Commander Dan Daspit, whose refusal to fire his last torpedo triggered the breakthrough, received a Navy Cross for his patrol. The citation never mentioned the torpedo test, just his extraordinary courage in combat. Daspit finished the war with 4 successful patrols, retired as a captain, and died in 1974. His obituary in the Honolulu Star Bulletin was 4 paragraphs. No mention of Tinosa, no mention of Tonenmaru No. 3, no mention that his decision changed submarine warfare forever. One submariner who survived the war wrote years later, "We called them the lost years, 1942 and 1943, when we fired perfect shots that turned into duds. Admiral Lockwood gave us back our confidence, gave us weapons that worked. Because of him, we came home." The Mark 14 torpedo, with its modified firing pin, remained in U.S. service until 1980, nearly 4 decades. Modern submarine commanders at the Naval Submarine School in Groton, Connecticut, still study the torpedo scandal as a case study in organizational failure and leadership courage. The lessons are taught in 3 parts. First, when field reports contradict laboratory testing, believe the field reports. Second, when operators say a weapon doesn't work, trust the operators over the engineers. Third, when regulations prevent solving life-threatening problems, violate the regulations. The U.S. Navy's current torpedo, the Mark 48, underwent extensive combat conditions testing before deployment, a direct result of lessons learned from the Mark 14 scandal. No modern weapon enters service without verification that it actually works when fired in combat. Admiral Lockwood died in 1967, age 76, at his home in California. His funeral at Arlington National Cemetery was attended by over 200 former submariners, men who'd served under his command, men whose lives he'd saved by giving them torpedoes that finally worked. The graveside eulogy was delivered by Admiral Eugene Fluckey, the former captain of USS Barb, recipient of the Medal of Honor. Fluckey's words were brief but captured everything. Admiral Lockwood taught us that courage isn't just facing the enemy. Sometimes courage is facing your own Navy and telling them they're wrong. He fought 2 wars, one against Japan and one against the Bureau of Ordnance. He won both. But perhaps the real lesson isn't about torpedoes or submarines or even World War II. It's about what happens when institutional pride matters more than truth. When organizations blame operators instead of fixing defective equipment. When bureaucracy values regulations over results. For 22 months, the finest submarine force in the world fought with weapons that didn't work. Not because the weapons couldn't be fixed, but because the people responsible for fixing them refused to admit they were broken. Charles Lockwood was a mediocre student who graduated near the bottom of his Naval Academy class. He had no engineering degree, no political connections, no reason to believe he could challenge the Bureau of Ordnance and win. But he had something more important. He trusted his submarine captains. He believed field reports over laboratory denials. And when faced with a choice between following regulations and saving lives, he chose lives. The Mark 14 torpedo scandal is military history's clearest proof that the most dangerous words in any organization aren't, "This is impossible." They're, "Everything is working as designed." Until someone like Charles Lockwood proves otherwise.